Hello guys, good morning. You are welcome to my YouTube channel, the Explicit Tutorials. As you all know, my name is Dr. Joseph. Please, as you are watching this video, endeavor to subscribe, like, share, and comment. In today's video, we shall be discussing wave in physics 113. Alright, please, as you are watching this video, endeavor to subscribe, like, share, and comment. But before we get into what we have today, let us make a very short prayer. In Jesus' name, in the mighty name of Jesus. Father, my God in heaven, we thank for your mercy, we thank for your love, and we thank for all that you do in our lives. We thank for your protection, we thank for your grace, we thank for your compassion, we thank for your forgiveness, and we thank for your mercy, for there is none like you. My Father, my God in heaven, we pray, we declare and decree, as we're about to learn, Lord Jesus Christ, may you give us the grace to assimilate in the mighty name of Jesus Christ. We neutralize every spirit of distractions as the class is about to commence in the mighty name of Jesus. And I pray that our future is blessed. Our destiny shall not be sabotaged in the mighty name of Jesus Christ. Our goal on earth shall not be thwarted by the evil ones in the mighty name of Jesus Christ. For I pray that we shall keep being covered by your shield. For we are protected. For in you our life is preserved in the mighty name of Jesus Christ. Thank you, Lord, for answers of prayer. In Jesus' name I've prayed. Amen. So let us get started. Physics 113, a topic called wave. Now this word wave is not a new word. Of course, we all know the meaning of wave. Very, very simple. What is wave? Wave is a disturbance. What did I say? Wave is a disturbance that propagates from one point to another. I'll recap. Wave is a disturbance that propagates from one region of space to another, transferring energy without the medium being what propagated. I'll recap. I said wave is a disturbance that transfers or that propagates from one region of space to another, transferring energy. All right, and its propagating medium is what is not displaced. Okay, that is the meaning of what wave. Now, on a broad note, we have two types of wave. Like we have classes of wave, classes of wave. We have one. We have mechanical wave. All right, and two we have electromagnetic wave. Now, these are the two classes of wave that we have. We have mechanical wave and we have what? Electromagnetic wave. Now, this first one, mechanical waves are waves that what? Require material medium. That require what? Material medium for their propagation. Alright, mechanical waves are waves that require material medium for their propagation. What are examples of mechanical waves? One, we have water wave. Water wave is mechanical, and we now also have what is called what? Sound wave. Sound wave and water wave are examples of what? Mechanical wave, because they require material medium for their what? Propagation. They require material medium for their propagation. What about electromagnetic wave? Electromagnetic wave are waves that do not require material medium for their propagation. They do not. These ones do not, but these ones do. Examples of electromagnetic wave are light wave, ultraviolet rays, X-ray, gamma ray, infrared wave, visible wave. All of these, they are all called what? Electromagnetic waves, because they do not require material medium for their propagation. But these ones require material medium for their what? Propagation. Examples are water wave, and what? Sound wave. Radio wave is also what? An electromagnetic wave. Take note of that. So these are the classes of wave: mechanical wave and what? Electromagnetic wave. Okay. Now we now have types of wave. Types of wave. We have one, transverse wave, and two, we have longitudinal wave. Transverse wave and what? Longitudinal wave. Now transverse waves are waves that propagate perpendicularly towards their propagation, right? Transverse waves are waves that propagate perpendicularly to the direction of what? Their propagation. I said transverse waves are waves that propagate perpendicularly to the direction of what? Their propagation. Please, all electromagnetic waves are transverse waves. All electromagnetic waves are transverse wave. But the only wave that possesses all the features of wave are light waves. Right? Light waves possess all the features or all the characteristics of wave, such as reflection, refraction, diffraction, interference, and polarization. Okay, light wave. Okay, say transverse wave, which light wave, which an example of transverse wave, has the ability to undergo what? Polarization. It is only light wave. It is only light wave, which is a transverse wave, that has the ability to what? Undergo polarization. Then as the class progresses, I'll give you the meaning of what? Polarization. I said these are waves that propagate perpendicularly in the direction of what? Their propagation. Examples are what? Light waves. All electromagnetic waves are what? Transverse wave. What about longitudinal wave? These are waves that propagate parallel. They propagate parallel in the direction of what? Their propagation. They propagate parallel in the direction of what? Their propagation. The keyword here is parallel. Parallel is to longitudinal. Perpendicular is to what? Transverse wave. Do not forget that. All mechanical waves are what? Longitudinal waves, which means that examples of longitudinal waves are sound wave and what? Water wave. Take note of that. It is very, very important. Now we also have other classes of waves. Other classes of waves. We have other classes of waves. So we have one. We have what is called standing or stationary wave. Stationary what? Wave. We have standing or stationary wave. What are standing waves or stationary waves? These are waves having the same frequency. They have the same frequency, velocity, and they have the same frequency, velocity, and time. All right, these are waves having the same frequency, velocity, and time. They're traveling towards opposite direction. Opposite what? Direction. All right. I said that standing wave or stationary wave, all right, it's a wave having the same frequency, velocity, and time, but they travel in opposite what? Direction. They travel in opposite direction. A good example of standing wave is one they call sinusoidal wave. Sinusoidal wave is what? A good example of what? Standing wave. Standing wave or stationary wave is a wave, or they are waves having same frequency, velocity, and time, but they travel towards what? Opposite direction. A sinusoidal wave is a good example of what? Stationary wave. How does this wave look like? Please take note of this. All stationary wave exhibit what is called what? Total destructive interference. Now, interference is also a feature of what? Wave. Now, please, standing wave or stationary wave, I said, they are waves having same frequency, velocity, and time. All right, but they travel in opposite what? Direction, and they are example of what? Total destruct. They are produced from total destructive what? Interference. All right, take note of that. Is there another point? Now, as this wave travel towards opposite direction, as it travel towards opposite direction, they meet at the end. At the end, they meet. Look at it here. I have something like this, and I have something like this. Okay. Look at what is going to happen. This will come like this. What I'm drawing now is sinusoidal. Look at the movement. Sinusoidal. Sinusoidal. So this one is traveling towards this direction, all right, but this one is traveling towards this direction, right, but this one will travel towards this direction. All right, so what I've just illustrated is what? Standing wave, or what? Excuse me, let me do this very well. Oh God, Jesus, I know what's past. Now, so what I've just illustrated is what? A standing wave. Look at the first one was moving to the right hand direction, but the second one moved to the left hand what? Direction. Looking at what we have here, there is always meeting point. They are going to meet. All right. What I've just illustrated is what? Standing wave. And standing wave is produced from what? Total destructive what? Interference. Please take note of that. It is very, very important. Sinusoidal wave is what? Standing wave. Take note of that. And we have two. We have progressive wave. Now, progressive wave is a wave. Progressive wave is a wave having same frequency, velocity, and time, but they travel towards the same direction. I'll recap. Progressive wave is a wave that have same frequency, velocity, and time, but they travel towards what? The same direction. Please, all progressive wave are produced from what is called total constructive interference. This place is bad. So which means that total destructive interference is to standing wave, while total constructive interference is to what? Progressive wave. I said these are waves that have same frequency, velocity, and time. But do they travel towards opposite direction? No. They travel towards what? Same direction. That is what? A progressive wave. Now let me show you how it looks like. You have something like this. All right, another one. All right, so what I'm illustrating now you see now what I just illustrated is what? I don't know if I should take it up. Is it showing? Let me check. Oh yeah, it's showing, so we'll leave it like that. So what I've just illustrated is what? Progressive wave. which is produced from a total constructive what interference. So this how what's it called now, progressive wave looks like, and this how standing wave look like. Now, what is the difference between standing wave and progressive wave? The difference is very clear. In standing wave, they travel towards what? Opposite direction, okay? But the progressive waves travel towards same direction. Please take note of that. Now, let us now look at the the terms associated with wave. The terms associated with wave. Terms associated with wave. All right? Terms associated with wave. Terms associated with wave, you have one, period. Period is denoted using what? Capital letter T. Alright, and it's measured in seconds. Now, the period of a wave means the time taken for a wave particle to make what? One complete oscillation or one cycle. The period of a wave means the time taken for a wave particle to make what? One complete oscillation or cycle. Now, period is given as 1 over f. Is also equals to 2 pi over this over w. All right, then you now have w to be 2 pi f. You see now, so period is 1 over frequency, then 2w over what? That is 2 pi over w, then w equals what? 2 pi f, which means that if I should put 2 pi f here, I'll be having what? 1 over f, because 2 pi will cancel 2 pi. I'll now be having what? 1 over what? F. So take note of that. That is what? Period. And it's measured in seconds. Now, 2, I have frequency. Now, frequency means what? The number of oscillations, all right? The number of oscillations or cycle that a wave particle covers in 1 second. I recap. Frequency means what? The number of oscillations or cycles that a wave particle covers in 1 second. And the SI unit of frequency is what? Hertz. Hertz. All right, like H what? Z. Now, the SI unit of frequency, which is Hertz, was named after the physicist called Heinrich Hertz. Heinrich what? Hertz. So the SI unit of frequency is what? Hertz. Do not forget that. Frequency is given as 1 over what? Period. 1 over period. Now, frequency is also equals W over what? 2 pi. W over what? 2 pi. Do not forget that. Which means if I have F equals W over 2 pi, if I should make W my subject formula, I'll not be having W equals what? I'll not be having W as 2 pi f, just as I had here. All right, so that is what? Frequency. Then number 3, you have what is called wavelength. Now, the wavelength is denoted using what? Lambda. Look at the word lambda. Now, wavelength means the distance between 2 successive crests or troughs. Wavelength means what? It means the distance between 2 successive, this is the word, crests or troughs. Okay, I would have explained these 2 terms on the board: crest and crest and what? Troughs. And the SI unit of wavelength is what? Meter. All right. Now let me illustrate something here. If I have this, all right. Now, the highest displacements of a wave particle is called what? Crest. This crest, this region, the highest displacement is called what? The highest displacement of a wave particle is called what? Crest. while the lower displacement is called what? Troughs. Troughs. All right, take note of that. Okay, I said wavelength means what? The distance between the distance from here to here is called what? Wavelength. And the distance from here to here is called what? Wavelength. You see, it is the distance between two successive what? Crest or what? Trough. Take note of that. That is number what? 3. Then number 4, you have what? Amplitude. Amplitude. Alright. The amplitude, which is denoted as what? A. The amplitude of a wavelength means what? The maximum displacement of a wave particle from its what? Equilibrium position. I recap. I said the amplitude of a wave particle means the maximum displacement of that wave particle from its what? Equilibrium position or what? Point. And the SI unit is what? Meter. Is in meter. Take note of that. So these are various terms associated with what? Wave. You have period, you have frequency, you have wavelength, and you have what? Amplitude. Take note of that. Okay, the next one we are going to be taking right now is what should I take next? Okay, let me give you. Okay, let me do this. I don't know. Should I take properties first before I give us a general formula? All right. Okay, let me take properties of waves. Properties of waves. Properties of waves. Properties of wave. Properties of wave. All right. We have 1. Reflection. Now, what is reflection? Reflection is a phenomenon characterized by change in direction as light rays are incidented on a surface. I said reflection means what? It's a phenomenon characterized by change in direction as light rays are incidented on a surface. Now, there are 2 types of reflections. We have the one that is called smooth or regular reflection. We have one is called what? Smooth or what? Regular reflection. And 2, there's what we call rough or irregular reflection. All right. Now smooth or what? Regular reflection, and we have rough or irregular what? Reflection. Now, if I have when light rays, okay, let me bring it down, please. We have this, all right. In smooth, you can see now that the surface of this plane is very, very what? Smooth. Now, I will call this what? Plane surface. All right, plane surface. Plane surface. Now, if light rays are incidented on the surface of this, on the plane, okay, I think it's not well drawn. Now, this one descending to the plane surface is called what? The incident ray. Now, as soon as it touches the surface of this, as soon as it touches this plane surface, it what? Refracted. All right. So this one is angle of incidence, but this one is what? Angle of what? Refraction. All right. The angle is very important. Look at this one is coming down, then the other one is what? Going up. And you now have what? Normal. This is what? The normal. So my marker is, this one is normal. So which means the angle formed here, is called what? Angle of incidence. The angle of what? Incidence. That one formed there is what? Angle of what? Refraction. Is called what? Angle of refraction. Now, but in the rough irregular, now as soon as as soon as light rays are incidented on this plane surface, it reflects. That is, there is no the rays that refract or that are produced are well arranged. In other words, I can do it like this. All right, so this one is coming down. Oh, sorry. This one is coming down. This one is going up. This one is coming down, and this one is what? Going up. So what I've just shown is what? Smooth or what? Regular reflection, because the surface is smooth and you can see this regular, and the rays produced are well what? Arranged. But in rough or irregular reflection, all right, as soon as light rays are incidented, look at the way rough looks like. All right, you see it's rough and it is irregular. All right, so as soon as light rays are incidented on this rough or irregular surface, you now have something like this angle of incidence. Now it will be like this angle of reflection. You now have another one like this. Now another one like this. So you have this angle of incidence, angle of incidence, angle of incidence. This one is angle of refraction. This one is angle of refraction, and this one is what? Angle of what? Refraction. You can see now that the rays, all right, the refracted rays are zigzag. They are not well. They are not well arranged, because the surface is what? Irregular, or it is what? Rough. Take note of that. Okay, so that is all about what? Reflection. Let me give you the rule of reflection. The first rule of reflection states that that is angle of incidence, normal, and angle of refraction are on the same plane. Of course, it's clear. Now, angle of incidence, angle of refraction, and normal are all found on the same plane. That is what? Law 1 of what? Reflection. But rule 2 states that the angle of, that is refractive index, hold on, refractive, or let me just put it like the angle of incidence is equals what? Angle of what? Refraction. Angle of incidence is equals what? Angle of refraction. And the so-called, okay, not yet. So I'll not give us that one. I'll give us when I'm taking us refraction. Okay. Oh god, the marker is bad. I said rule number 1 said that the incident ray, or the incident ray, the refracted ray are all found on the same plane. And the second law states that the incident ray is equals what? The refracted ray. Do not forget that. Please take note. NB. Don't forget this. This is a plane surface. Now, this is what we call angle of glance. Angle of what? Glance. So this is the angle of glance. The angle of glance means the distance between the plane surface and what? Angle of incidence. Now the distance between angle of incidence and plane surface is called what? Angle of glance. I'll denote as what? G. I repeat, angle of glance means the distance between the incidence ray and what? The plane surface. All right, take note of that. Now, please, what's it called now? The angle of deviation. Oh god, the angle of deviation. The angle of deviation is twice the angle of what? Glance. The angle of deviation is twice the angle of what? Glance. And angle of deviation is given as what? 180 minus. All right, so this is the formula. That is angle of deviation is equals 180 minus incidence, angle of incidence plus what? Angle of what? Refraction. So whatever you get here, to get a glance, angle of glance, you divide it by 2. Let me give you a question on that. So please take note that angle of glance is the distance between angle of incidence and what? Plane, or that is the plane mirror or the plane what? Surface. Do not forget that. Okay, what if we were given a question like this? Like in an experiment, it was observed that angle of incidence, let me just write in the full, angle of incidence was 35 degree, and that of refraction was 35 degree, and we've been asked to calculate the angle of glance and what? Angle of what? Deviation. If you want to illustrate this, this is what you are going to do. All right, so of course you have the normal. Now what's the now? Now this place of course is angle of incidence, so you put 35 degree here, and here you have what? Angle of refraction, 35 degree. Now this place is the angle of glance, and here is another angle of what? Glance. All right, so how do you solve it? You say g plus g, that is 2g, right, plus 30, that is 35 plus 35 is equals what? 70, then equals what? 180. Why is it 180? Because angle on a straight line is equals what? 180 degree. So 2g is equals what? 180 minus 70. 180 minus 70. I'll now have that 2g is equals what? 180 minus 70 is what? 110. So what do? You divide both sides by 2. So angle of glance now is equals what? 55 degree. Now that is what? Angle of glance. Now to get the angle of incidence, angle of deviation, you have what? 2g, which means that AD is equals what? 2 times 55, and AD is equals what? 110 degree. Now, if you don't want to make use of this method, you can use the formula I gave us. I said that angle of deviation is equals what? 180 minus. Now, when we sum up the incident angle and the refracted angle, we had what? 70, right? So AD is equals 180 minus 70. You have what? 110. Okay, so that is it. If you don't use this method, you can also use what? This formula. You can give us before that AD is equals what? 180 minus I plus what? R. Alright, so please take note of that. It is very important. Please know the difference between the that is angle of glance and what? Angle of deviation. It is very, very important. That is what? Reflection. Now the next one is refraction. 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 All right. Refraction is a phenomenon characterized by, okay, one, I said reflection. 2, we have refraction. Now, in refraction, when light rays are incidented on a plane, let me take it down. When light rays are incidented on a plane, what happens? They will change direction. The what? Change direction. Now, what this is that is angle of incidence. Okay. Now, in refraction, there's something I have to let you guys know. In refraction, we have we have what is called frequency, we have velocity, we have wavelengths, and we have direction. We have frequency, we have wavelengths, we have what? Direction. Don't forget an angle is formed here. An angle is formed. Zenith angle. Then now in refraction, the frequency remains constant. It never changes. In refraction, the frequency remains constant, which means that it does not change. But velocity, okay, direction changes, right? You can see the direction has changed, but the velocity and wavelength vary. I recap. Which of the following is true during diffraction? A. Frequency varies, velocity and wavelengths remain constant. The direction remains the same, frequency is constant. Frequency is constant or it remains the same in diffraction, but all of these vary. It's change direction, wavelength and velocity, they vary. Please take note of that. Take note of that. Now, the refractive index of a wave particle. The refractive index of a wave particle means what? The ratio of the sign of incidence over the ratio of the sign of what? Refraction. All right, and this was stated by Snell. You call it Snell's law of what? Refraction. You call it what? Snell's law of what? Refraction. Now, the angle of that is refractive index is the ratio of the sign of incidence over what? The sign of what? Refraction. It is very, very important. Refractive index. Please take note of this. That when light rays or when wave particles travel from deep to shallow region, all right, take note that when light rays, all right, travel from deep to shallow region of water or maybe sea, what happens? The wavelength becomes shorter. The wavelength becomes what? Shorter. Please, I recap. When light rays travel from deep sea to shallow sea, what happens? The wavelength becomes shorter. It becomes shorter. So you see that wavelength is what? 2. But when it travels from shallow region, when it travels from when the light rays or wave particle travel from the shallow region to deep region, what happens? The wavelength becomes what? Longer. And you now have what? Lambda 1. I said that when light rays or when wave particles travel from deep to shallow region of sea, the wavelength becomes what? Shorter. But when it travels from shallow region to deeper region, what happens? The wavelength becomes what? Longer. Which means that increase in the movement towards the deep region result to what? A decrease in what? The wavelength, okay? Which means that movement from deep region to shallow region result to what? Increase in what? The wavelength. V's are V. Please take note of that. It is very important. Then number 3, you have what is called diffraction. Diffraction. Now, what is diffraction? Diffraction is a phenomenon characterized when a wave particle, all right, diffraction is characterized when by the bending of wave particle round an obstacle, all right, which means that as soon as light rays are incidented on this surface, what happens? There's what? Bending of wave particles round the obstacle. Please, diffraction is the process whereby wave particles are found bending round an obstacle. Now, diffraction is usually caused when light rays pass through tiny openings, aperture, or what? Slits. All right. Now, diffraction, I said, is the bending of wave particles round an obstacle, and it is produced when what's called when wave particles pass through tiny openings, aperture, and what? Slit. Take note of that. It is very, very important. That is what? Diffraction. Then number four, you have what is called polarization. Polarization. Now, I told you guys about polarization. I said that transverse wave, light wave, which is an example of transverse wave, can only undergo what? Polarization. What is the meaning of polarization? It is a confinement. Don't forget this word. It is what? The confinement of a wave particle called what? Light particle towards one direction. All right, I said it is a confinement. It is a confinement of a wave particle towards what? One direction. All right, one direction. So we also have what is called plane polarized light. Plane polarized light. All right. A body, okay, there's what we call plane polarized light because there's what we call shearing. All right, light is able to undergo polarization because it can vibrate. It can vibrate or what? Or fluctuate. All right, the fluctuation or vibration of light rays as it passes through one direction is called what? Polarization of light, or like plane polarized light. When light is confirmed towards one direction, you call it what? Such light has undergone what? Polarization. Okay, now light is able to undergo is being okay, can be polarized, or it can be polarized. It can vibrate or what? Fluctuate. So that is number five. We also have we also have number five called interference. Interference. Interference is a phenomenon. Interference is a phenomenon in which two waves which are coherent cross each other. All right, when two waves cross each other, such process is called they have undergone what? Interference. All right, they have interfered with themselves or with each other. Now, when two waves cross each other, what do you call that? Interference. Now, I told you guys that we have constructive interference, we have partial constructive interference, we have destructive interference, and we have what? Partial destructive interference. Now, when two waves are moving towards opposite direction, such wave has undergone what? Constructive interference, like what I showed before. I illustrated it before. Like they are traveling towards same direction. All right. All right, so what I've just shown is what? An example of what? Constructive wave. All right, I told you that in a constructive wave they travel towards what? Opposite. In a destructive wave the wave travel towards what? Opposite direction. One is traveling to my right hand side, the other is traveling to my left hand side. All right, so that is what you have it to be. This one is destructive, while this one is what? Constructive. So I've given us all the properties of wave, the terms associated with wave, okay, but there's something I have to do. Now, I told that progressive waves are waves having same frequency, velocity, and time, but they travel towards what? Same direction. The opposite is what? Standing or longitudinal. Okay, standing or what? Stationary what? Wave. Good. Now, progress. Okay, before I go into that, let us take different types. How do I put it now? Different types of velocity. All right, different types of what? Speed propagation. We have one. We have phase velocity. Like different types of velocity. We have phase velocity, that is v, and so we have particle velocity, that is vp, and three, we have group velocity. Hope it's recording. Yeah, we have group velocity, and we have what? Vg. Now, what is the meaning of what? Phase velocity. Now, phase velocity is that velocity in which the phase of the wave propagates through what? The medium. It is the rate, it is a measure of the rate in which the phase of the wave propagates through a given medium. Or you can say it is a speed. It is a speed in which a wave particle uses to what? Travel. I said, if you don't say the rate at which the phase of the wave propagates through a medium, you can also say that it is a wave, it is a speed that a wave particle uses to what? Travel. Now, what is the formula of phase velocity? Which is v is equals w over what? K. W over k. I know that w is what? 2 pi f. I now, and k is what? 2 pi over what? Lambda. If I want to simplify this, I can have it to be like this. Now this becomes 2 pi f over 2 pi times 1 over what? Lambda, which means that this can go into this. All right, 2 pi f, and you have this over lambda. I think I'm doing it well. Times, yes, definitely. If I want to re-express this, I can say 2 pi f over lambda, okay, over 2 pi divided by lambda over 1. So once this division becomes times, lambda comes down and this one goes up. That is what I did. All right, so doing that, and I have that v is now equals what? 2 times 1, 2 over what? Lambda. All right, so please do not forget that the speed in which a wave particle uses to travel is called what? Phase velocity. Please take note of this. A type of medium in which the phase velocity, a type of medium in which the phase velocity depends on the frequency. I recap. The type of medium in which the phase velocity depends on the frequency is called what? Dispersion what? Medium. Dispersion medium. Please do not forget that. It's called what? Dispersion medium. A medium in which the phase velocity depends on what? The frequency. Don't forget that. The phase velocity, or if you don't call it phase velocity, you can also call it wave speed. Wave speed. All right. It determines the mechanical properties of waves. It determines the mechanical properties of what? Waves, which could be elastic or what? Inertia. Do not, which of these determines the chemical strength or properties of waves? It is what? Phase velocity. A type of medium in which the phase velocity depends on the frequency is called what is dispersion what medium. So that is what we have it to be. And number two, we have particle velocity. Now particle velocity means what? The velocity that a body uses to oscillate at the point of what? Equilibrium. Equilibrium. All right. Particle velocity is the velocity required by a wave particle which it uses to oscillate at the point of what? Equilibrium. At the point of what? Equilibrium. Do not forget that. Now we now have the group velocity. Group velocity. Now, when waves, okay, or you can say group velocity is characterized by the process whereby different or waves of different wave of different frequency, velocity, and time. All right, I said that group velocity is a velocity possessed by a wave of different frequency, velocity, and time, and they are superimposed. They are superweighting imposed. All right, the wave that is waves, the process whereby waves of different frequency, velocity, and time are superimposable. You say they are called what? Group velocity. They are called group velocity because you have this, and this. They are now superimposable. All right. So please, group velocity is given as, oh God, group velocity is given as W1 minus W2 over K1 minus what? K2. What would I have? I'll have W over what? K. Alright, so that is what? Group velocity. These are three types of velocity used under wave. Phase velocity, otherwise called wave speed. We have particle velocity, and we have what? Group velocity. Alright, group velocity is that velocity in which waves having different frequency, velocity, and time are what? Superimposed. They are superimposed. Okay, so we now have what is called the speed of transverse wave and the speed of longitudinal wave. We have the speed of transverse wave. All right, now the speed of transverse wave, all right, is given as v over, okay, v equals the square root of t over what? All right, now t is the tension, t is the tension, and the SI unit is what? Newton. You now have this sign. This sign represents what? A linear density mass. All right, linear density what? Mass. If you don't want to call it linear density mass, you can also call it phases per unit length. Per unit what? Length. You can therefore see that the speed of transverse wave is dependent on the tension and what? The linear density mass, or phases per unit what? Length. Please, that is what you have it to be. Speed of transverse wave is given as this. Do not forget that. Now number two, you now also have what is called speed. Speed of longitudinal wave. The speed of what? Longitudinal wave. Now the speed of longitudinal wave is given as, okay, transverse, I'll use T, then VL, longitudinal, equals the square root of B over P. All right, not just a P, this is a sign. All right, B represents what? Bulk modulus, and P means what? Density. Right, which means that the speed of longitudinal wave is dependent on the Bulk modulus and what? The density. Now, what I've just given us is the speed of longitudinal wave in a fluid, in waiting a fluid. All right, in a fluid. Do not forget that, please take note that Bulk modulus is given as what? 1 over k. Oh, good. Bulk modulus is given as what? 1 over k. Do not forget that, which means wherever I say my b, I can try to put what? 1 over k. What I've given us is the speed of longitudinal wave in what? A fluid. Okay. So you now also have speed of longitudinal wave in a solid. You say v equals okay, let me just do it as liquid. Then velocity of longitudinal wave in what? Solid equals the square root of lambda over what? P, gamma rather. All right. Now, what this sign here? This sign represents Young's modulus. Young's what? Modulus. So the speed of a transverse wave is given as this. All right, but the speed of longitudinal wave in a fluid is given as this, but the speed of longitudinal wave in a solid is given as what? This. Please take note of that. It is very, very important. Now, please, the propagation speed of transverse and mechanical wave are dependent on their mechanical what? Properties. All right, which means that the speed of transverse wave and the speed of longitudinal wave are dependent on what? Their mechanical properties. Do not forget this criteria that I've been given. Now, speed of transverse wave depend on what? Tension and this linear density mass. But what about speed of LW? Like we have bulk modulus and what? Density. What about the one in solid? Modulus and what? Density. Both of them are dependent on what? The mechanical what? Properties. Do not forget that. Now, the speed of a wave particle. Now, the speed of a wave particle, of course, is given as the product of frequency and what? Wavelength. Now, okay, V is equals the product of frequency and what? Wavelength. All right, so which means that V is equals what? F pi. Do not forget that. So I've given us all that we need in this topic, wave physics 113. Okay, but the one I'm going to be rounding off with is the general formula of progressive wave. The general formula of a progressive wave. All right, I think I'll get a better marker. Don't know. So you have y equals a sine open brackets wt minus phase angle. Minus what? Phase angle. This is the general equation of what? A progressive wave. But that is not it. Don't forget that phase angle is equals what? Kx. Phase angle is equals to kx, and k is also equals to 2 pi over what? Lambda. Now what I've just done, everything here is called what? Wavelength number. Wavelength what? Number. All right. wavelength number. That is what you have this k to be. Everything here is called wavelength number. Okay, wavelength, that is this idiot. We now have here wt. All right, don't forget I told you that w is equals what? 2 pi f. 2 pi f. Now w is also equals to 2 pi v over lambda. This same w is also equals to 2 pi over period. Now this is the general equation. This guy is equals to kx, and k is equals to 2 pi over lambda, and this is what? A wavelength number, everything here. Now, what about w? W is what? 2 pi f equals, this same w is also equals to this, and this is equals to what? This. Now, let us start substituting. All right, so I'll rub off this one. So I'll divide it because it's going to be a long one. Now, from your equation, I have that y is equals a sine, open brackets. Wherever I see w, I'll put what? I'll put what? 2 pi f. Okay, should I start with that? Okay, not yet. I'll write wt minus, wherever I see the phase angle, I'll put what? Kx. Kx. This equation, what? 1. Is it clear? I know it's very, very clear. All right, so this one is what? Equation 1. Now, again, y is equals a sine, open brackets, w, I said is what? 2 pi f. 2 pi f. Don't forget t minus what? Wherever you see k, you put what? 2 pi over what? Lambda. Don't forget there was x here. So this k has been replaced by 2 pi over what? Lambda. So what do you do next? You have 2 here, and you have 2 pi here, you have 2 pi here, and that means that you are going to what? Factorize. In doing that, you have y is equals a sine, a sine 2 pi, which means you will have to bring out 2 pi. You now have that, open bracket, you are left with what? Ft minus, you are left with what? X over what? Lambda. X over lambda. So this is equation what? 2. Just follow it step by step. Now from this same, we are going to be using this equation to get everything that we need. Now we also have that y is equals a sine, open brackets. I told that w is also equals what? 2 pi v over what? Lambda, right? 2 pi v over lambda. So I have that 2 pi v. Don't forget there is a, where is it? Okay, there's a t here. This w is what I've just written as this. So don't forget your t over what? Lambda. Then what do you now have? Minus your k. Don't forget your k is definitely 2 pi over what? Lambda. Your x was there. Now what do you have in common? Looking at what we have here, 2 pi over lambda. 2 pi over lambda is what? Common. What do? You factorize. So you say y is equals a sine 2 pi over lambda. You open a bracket. What are you left with? Vt. You have Vt minus x. This equation what? 0. It is very simple. So just follow it step by step. Now that you have brought out 2 pi over lambda, you are left with what? Vt minus, you brought this one out, you are left with what? X. That is what you have there. Now the last step, I have that y is equals a sine, open brackets. I told that w is also equals what? 2 pi t. And this t here means what? Period. Now I'll put 2 pi. Oh god. I'll put here 2 pi over what? T. Then you know there was where is it again? And there's a t here, so you are not to forget that t minus k. Don't forget it's always 2 pi over what? Lambda. 2 pi over lambda, then what's x? 2 pi over lambda x. 2 pi over lambda what's x? What do you observe here? You will observe that y is equals 2 pi, 2 pi. You have, okay, I think we did something like that here just now. Where is it? Okay, you have 2 pi, 2 pi. You are not to factorize. Do you know why you cannot factorize? Because this 2 pi is affecting, is not affecting this one, all right? This 2 pi is not written here, right? It's affecting this. So what do? You simply eliminate. You now have a sign. You have removed your 2 pi. Now you will be left with what? T over period. T over period. Then minus, I think, wait, let me check this stuff very well. Yes, you can actually factorize. Yeah, you can. So you now have 2 pi, open brackets, t over what? Period, then minus, okay, minus x over what? Lambda. Minus x over lambda. Because 2 times this is 2 pi t over period. Then minus 2 times this is 2 pi x over what? Lambda. That is what we have here. So this is what? Equation 4. So these are the 4 equations of wave, all right? So just follow it step by step. The first thing you do is to write out these 2 idiots. The things here must be written out first before you start substituting and having your values, okay? It is very, very important, okay? So please do not forget the comparison, how we did it and we arrived at this point, okay? So is there any other thing that I should be telling us? Let me check. Okay, so we are done, we are through. So the next thing we are going to be doing is what? Solving questions. But because I've spent a lot of our time doing this, I will solve just one question, and after which the next video I'll upload will be on the exercises you have on your textbook. As soon as I round off this video right now, I'm going to be taking it. But before I just call it a day, let me give a question so we use any of these to solve. Okay, I think I have a question here. I have that y is equals 4 sine 100 pi t minus 50 pi x. Now we have to find the amplitude, the frequency, the wavelength, and what? The speed. We can also find the period. Now, from what I gave you, I know that A is always your what? Amplitude. It therefore means that your amplitude is simply what? 4 meter. That is just the answer. Don't kill yourself. They've helped us to get the answer, and we really appreciate them for that. So it means that A is what? 4. You have 4 meters. Now to not get the frequency, now looking at what we have here, I know that W is equals what? 2 pi f. 2 pi f. 2 pi f. Now, looking at what we have from the original equation, what is occupying the space of W? It is what? 100 pi. So what will you do? You write 100 pi here. 100 pi equals 2 pi f. All right, 2 pi f. So you want to make f the subject of the formula. So you say divided by 2 pi divided by 2 pi. All right, so this will go into this. I'll know that f is equals, I think this pi cannot cancel out this pi. Okay, so 100 divided by 2 is what? 50 hertz. That is the answer. Very, very easy. Very, very easy. Just compare it. Looking at W, it's being displaced, or it's being represented by 100 pi. Just bring it out, compare, you have your answer. So which means that frequency is what? 50 hertz. 50 hertz. Now to get the wavelength, which is lambda, to get the wavelength, what will you do? number, copy your wave number, compare it. You have that. Now looking at k, where do you have, okay, what do you have occupying the position of k? From the equation you have 50 pi, right? 50 pi. So it means I write out 50, you write 50 pi equals 2 pi over what? Lambda. 2 pi over what? Lambda. So you have to cross multiply. Definitely, you say 2 times this is 2 pi equals, you now have 50 pi this. So pi will cancel out pi. Yes or yes? Yes. You therefore say that lambda is equals, that is, you have to divide both sides by 50, right? Which means that lambda is equals what? Is that not correct? Yes, 50, which means that those 50 going to 50. Lambda therefore means that 2 over what? 50, because you have divided both sides by what's attached to what? Lambda, and that is 50. So 2 divided by 50, 2 divided by 50, 2 divided by 50 equals 0 0.04. Alright? It means that lambda now is equals 0 0.04 meter. Don't forget their SI unit. So we have gotten lambda, we have gotten frequency, and we have gotten what? Amplitude. So what is the next one we have to look for? All right, I'll leave this one. So we'll look for the velocity or the speed. I told us that velocity is equals what? Pi lambda. So velocity is equals 50 from our, we got 50 as our frequency, the lambda as what? 0 0.04. 0.04. So velocity therefore is equals 50 times 0 0.04 equals 2, which means that 2 meter per waiting second. Our velocity is 2 meter per second. 2 meter per second. Okay. So what is the next one? Let's calculate the period. The period. Of course, you know to calculate for the period, it is easy peasy. Period is equals what? 1 over f. That's 1 over what? 50. Because we got f as what? 50. It therefore means that 1 divided by 50 equals, period is equals what? 0 0.02 seconds. 0 0.02 seconds. If I were to express this in standard form, it becomes 2 times 10 raised to the power what? Minus what? 2 seconds. Alright, so at this point, we'll call it a day. In our next video, I'm going to be solving all the questions you have, that's all the exercises you have in this topic, I believe. So at this point, we call it a day. Thanks for watching, and endeavor to subscribe, like, share, and comment. Do have a wonderful day.